amazing speakers that we have. So first we have Mario Guagnelli, who's the CEO and co-founder of IntoConcrete. He has over 20 years of broad and diversity manufacturing, IT, and executive experience in corporations across North America, Latin America, and in Europe. He worked for Lafarge, and where he was a member of Lafarge's U.S. Executive Committee. Mario has a Bachelor's of Engineering in Mechanical and Industrial Engineering from Tec de Monterrey, Mexico. He received his executive education diploma at INSEAD Business School in France and executive MBA degree from Northwestern University Kellogg School of Management. Mario lives in Atlanta, Georgia, and very, very special guest to have here with us. And then we also have Frank Corvi. And Frank Corvi is a design manager of IntoConcrete since the inception in 2013. He's an industrial designer, 3D artist, and consultant based in Tendo, Argentina. Fran has collaborated with many companies and entrepreneurs worldwide, developing and launching new products from concept to production. He also worked for multinational corporations as a freelancer project manager. Fran has a degree in industrial design from the National University of La Plata in Argentina. So you guys can see, they know what they're talking about. Very special to have them here. And thank you, Mario and Fran, for joining us. And take it away. The stage is yours. And do your thing.
Thank you, Mateo. And well, thank you for the intro. And thank you to Sunken Blimp, to Mateus, and to Camilo for inviting us. It's a very new thing to us, and this is the first time I actually use a headset like this in a setting like this. So I'll try to do my best. Very, very excited. I'm really into innovation, and this was a great opportunity to learn about new technology like this, but more importantly, to get a chance to interact with a lot of designers and people who like innovation, and hopefully, at the end of this conversation, you have a better understanding or a different understanding of concrete, and the good, the bad, and what you can do with it, especially for designers and architects to have a new perspective on concrete. So, as Mateus mentioned, I work with Fran. Fran is over here. We've been working together for almost 8 years. So we founded IntoConcrete first as a way to bring designs kind of to the mainstream that are based mainly on concrete. And so we started in Chicago, and in some places you'll see that our name, IntoConcrete, it says IntoConcrete Chicago. We started there, and we actually design and produce some of our own products. And recently, in the last 2 years, we've been focusing more on helping designers bring their ideas, especially in the U.S. market, although we serve the whole market, the world market. So actually, if I go to the next slide, and so as of now, we're trying to create a global movement of small but growing community of concrete artisans and designers. One thing I wanted to do first is actually to dedicate this to all our amazing designers, partners that work with us and that trust us to bring their products to the market. We have partners pretty much all over the world, in Canada, in the US, Taiwan, India, Hungary. And so if you want to learn more about them, which they're really what is, the heart of IntoConcrete, you can go to our website. We have a section and we have a bio on each of them. These, for instance, these are a candle that is made of concrete with soy wax made by Construct in British Columbia in Canada. So, okay, let's talk about concrete. Let's see. I don't think I need to convince anybody here that concrete has a certain appeal that, it's you see it everywhere, and and it's been um, a big part of our civilization. You know, I have this photo here of the Pantheon in Rome, which is about 2,000 years old, still standing. We have, you know, the Calatrava architecture. We have huge bridges. This one is in France. I think it's the tallest bridge, or it has some kind of record. Also, you may be familiar with this is from Luciano Krug in Argentina, and there's some architects that are really using concrete in its very raw form, and it's, you know, it can become a very spectacular aesthetics and so this is also a very known building in Chicago. Well, a couple of buildings, and again, I mean, concrete has a certain appeal. I don't know if it's that it's a mineral, you know, that is the color, the texture, but it's a great product. Now, what you hear right now in the news is concrete is bad for the environment, and yes, there are some things that we need to be discussed, right? The main issue with concrete is that it's the second most used material in the world after water. So, you know, it's the amount is so huge that that's what is causing, you know, some or it's getting so much attention. But I'm going to focus on using concrete for design, and that's kind of the next slide, which I'm trying to debunk some of the myths about concrete. The first one is that concrete is not a green material. As I mentioned before, and I'll talk a bit more about that, that it's not really, you know, it's good for handcrafts and other things, but not really for precise products. And it's also hard to produce at scale. So let me start with the first point, which is it's not a green material. I'm gonna dare to say that, especially when it's used for designing products, concrete is one of the greenest materials that you can find. Why is that? Okay, so there is something called embodied carbon, and this study is for building materials, where, you know, there are scientists and, you know, very smart people that look at each of the materials and end to end, what is the amount of carbon that was produced, right? So from the extraction, from the processing, from the transportation, and even for disposing of those materials. So based on that information, we see that concrete, which, let me actually do a parenthesis here. Probably a lot of you are aware of this, but concrete is not cement. Cement is the binder, which is part of concrete, but concrete in reality is a mix of cement, the binder, aggregates, and sand, and a few other things, but that's really the basic things, and water. So you can see that concrete is 0.1 kilos of CO2 per kilos of concrete. Cement, which is just, again, it's not used as a unique, as a standalone product, but even that is 1 kilo per 1 kilo of CO2. So then, why is it that when you see the news that we're talking about, you know, concrete produces something like 8% of all the CO2 annually, and again, the reason is just the huge volume of concrete that is produced. So when you see a bridge like the one I showed you, I mean, those are thousands and millions of tons of concrete that is used. Now, if that bridge was made of steel or you know, any other material here, it would be 10 times, 20 times, you know, in a kilo by kilo, right? This is based on mass. So that's the first thing. In reality, it's if you take just mass to mass, you know, it's less. It has a lower carbon footprint than other materials. The other thing that is kind of interesting is that this is not also publicized a lot, but concrete actually absorbs CO2 after its curing. You know, concrete and cement, for the most part, is calcium carbonate, is limestone, that is calcined. So when you put water in it and it becomes solid again, this material is trying to get that CO2 back from the atmosphere to become limestone again. So now, one of the issues is that if you have a huge block or a big column of that bridge, only the exposed parts are going to be the ones who are going to be absorbing CO2. A road, like a concrete road, may absorb more because it has more surface. In our case, in the case of design, small products, pretty much all the surfaces are going to be exposed and it's going to be capturing CO2. It can be recycled infinitely, and it can be reused in buildings, in any part of the supply chain of concrete. Now, this is another point that is also very important. And as Mateos mentioned, I was in the cement industry, and that's one of the things that that motivated me to do this. But I don't know if this is well known, but cement kilns use alternative fuels. Of course, there's gas and there's other fossil fuels, but there's a lot of alternative fuels like plastics, like even things like seeds that are not used, and instead of spoiling, they use as alternative fuel. Now you're going to tell me, well, but this is generating more emissions. Some of these products, when you so a cement kiln burns at an extremely high temperature. It's actually pyrolysis that is happening there. So those materials are decomposed to their elemental state. So, and many of those actually become part of the cement that is produced. So, cement is also responsible for avoiding a lot of plastic to get into, landfills and the ocean. And the last thing, and this is how I transfer to the next slide, is that one thing we like about concrete too is that it's kind of a back to basics. I think one of the reasons that we are throwing away so much stuff and we're using so much plastic is because it's cheap. It's we're more concerned about producing it in mass than producing something that is beautiful, right? So let me show you this. When you see like a nice bucket like this one, and you compare it to the very nice design by my good friend Frank Corvi, which one do you think you're going to be more likely to throw away? And even the price may be slightly higher, but it's not that much, right? So if this is plastic acrylic, and then see the other one, that also has a function, right? Because of its mass, you can put it in the fridge, and you'll be able to cool your favorite wine. Same thing for a watch. I mean, this is a mass-produced watch, and then our good friends of 22 Studio in Taiwan, they're producing these beautiful watches where they're using the face of the watch is made of concrete, and they also producing pens, and there's other things. But again, this is we're not saying we're going to make cheaper products, right? Ideally, at least they should be about the same price. But when you have something like this, I think it's going to be something that, like, if you compare this watch to this watch, I think the second watch is something you're going to want to keep in your family and give to your kids or grandkids, right? This, I'm not so sure. And even a Mont Blanc, this is probably 3 times the price of this, or 5 or 10, I don't know exactly. But it's also plastic, and it's more common, right? So this is something also that it's new. So our customers, I mean, if you see the reviews, you can imagine how holding a Mont Blanc feels in your hand. For those who haven't ridden with concrete, it's a different experience. So there's also something new about using this material in things other than buildings and roads. The next thing, if I can move to the right, the third misconception is that concrete, when it's used for product design, it's only for very rough designs and little planters and stuff like that. And I wanted to show you a few things. Some are ours, some are not. But like from 22 Studio, look at this clock. So the clock has, usually when you make something of concrete, a little bit like the lamp we're going to make later together, the back is hard to make it very fine and defined because of the way you pour concrete, right? But look at how thin it is, and you know it doesn't have any rough parts. Every part of the clock is very precise, and then you can install the machine, right? So this clock is replacing, or can replace, you know, something made of aluminum or plastic or a mix. By the way, something very important I forgot to mention. I'm not advocating for not using other materials, right? I'm just saying that in some cases, you can include concrete, and that would make it nicer, and you have all the benefits that I mentioned before. Yes, I think somebody, no, Praveen? I thought you had a question. Okay, there's other examples here. So these lamps are from Foscarini, and they've been very popular. They're also made of concrete, UL certified, and again, this is something that I think you would want to keep for a long time. The next one is a espresso machine. Now, here's another thing to notice. Concrete also can be used or can be produced in a way that is very smooth, like in the clock, but you can still play around with the texture, right? Like these guys at ANSA Coffee. And this espresso machine is going to last forever, right? Not only because of the material that is durable, but also because, I mean, who's going to want to throw this away? So again, it's mainly concrete, but it has obviously all the different parts. We're not going to make valves or, you know, stuff that has to be in other materials with concrete. And the last one is actually a speaker that we're developing with our friends at 22 Studio. And this speaker is, I don't know, maybe like 30 inches high. I don't know, like, anyway, it's like, I don't know if this is showing, but well, you can see the chair, just to give you an idea, right? So this is the largest product they produced. This is going to be released as a crowdfunding project, and it's a mix of different things. Now, the concrete part, it's very precise, obviously, so you can install the speakers, but also it has a function. You know, concrete also can be used for different things, for thermal properties. This is one of the other thing here is that for acoustics, when you have a speaker, especially for this range, I guess that's the high and the medium range, you want to have something that is not flexible, right? So concrete is extremely rigid, and for this thing, it's not just about the aesthetics, it's also going to help with the performance of this speaker. And there's a subwoofer, so this box is it's going to be in 3 different materials, and it's going to be Bluetooth. So again, I don't know if this changes your perception about the kind of things that can be made with concrete, but again, this is not kind of a theory. These are things that, at least the ones on the left, that you can buy and that, you know, are beautiful. So the last, before we go into kind of our workshop, is again, I mean, you can go to a hardware store and get cement and sand and everything, and yes, you'll face some challenges, and so, but we have been dealing with, you know, with these kind of challenges, and, you know, ourselves when we were producing, and also our partners. So, but all these things can be overcome. So, first one, you'll see in our lamp that now it's super easy and cheap to produce molds, from making the, you know, the base model to producing the, you know, what we call the shell of the molds. Like in this case, this is a 3D printed mold. You know, inside and everything is 3D printed except for the concrete, right? That is poured now, which is the second part. which, you know, when you produce something that is as thin as this clock, if you use regular concrete, concrete tends to be very thick. So they're super plasticizers, so you don't have to add a lot of water. You know, if you add too much water to concrete, it becomes very weak. So um, companies like BASF and Lafarge and many other companies have produced these super plasticizers. So you use a fraction of the water you would need with a normal product to give it this kind of fluidity that you can see in this picture. I mean, it's almost like water. But this is not because it has a lot of water, it's just because it has a super plasticizer. The next part is, okay, I want to produce 1,000 lamps or 1,000 bowls like this one. This was a bowl we produced for a company called Nambe. And so that means in normal circumstances, producing one piece of concrete, it takes 1 day to cure, right? So if you wanted to produce 1,000 of these a day, you would need 1,000 molds. If you compare that to plastic or to injected aluminum, then you see why the scale is so different. Now, there's accelerators, and with our own experience, we've been able to produce a product like every 30 minutes out of a mold, right? So again, it's obviously not the same production as of now. I mean, you cannot go out and buy a concrete injection machine like you can plastic or aluminum, right? And that's actually, by the way, a great opportunity. But you can do some of these things, and you can increase the productivity, tenfold or 20-fold by using some of these things. And finally, there's also some concerns about, is it fragile? Is it too heavy for this application? By the way, you can see some of the jewelry that we have in our store, and it's super light, right? And it's concrete. But, by making it thin and by adding some additives, you can make it lighter, you can make it stronger. And these are not, space age additives. These are things like, fiber and some polymers and stuff like that, right? So again, I think that before we go into showing you some a product, just wanted to summarize that there's a big opportunity for concrete to, not only to bring some joy in beautiful designs to our homes, but to help designers innovate, right? It's not easy, but all the things are in place to, to produce these beautiful products, and also, like in our case, we've been kind of leading the marketing of these products. So, for instance, some of these products you won't find in Etsy, right? Because they're not kind of the Etsy type of product that you would find there. But also you don't find them in Amazon. So we're building this community as well, just to give a platform to designers that want to sell these products in, which right now they are premium, but as we produce more and as more designers look into this, it's going to be easier to for other people to access. So before we go into the next phase, I don't know if you have any questions about what we've seen so far. Okay, I see Carlos. Welcome, Carlos. Say hi, Carlos. You're on mute.
Hey, everyone.
Okay, this is great. Okay, so again, the main objective for me was, first of all, to kind of present this. I'm not trying to convince anybody, but I think I want to try to make an argument about, supporting the use of concrete. Now, what do I mean by saying, okay, you can produce something that anything, pretty much any small items that can replace other kind of products. So we wanted to show you something that we actually did for one of our customers, which is this lamp. And there's some interesting things about this lamp. it's super simple, and that's one of the reasons. I mean, we don't have 3 hours, so we wanted to use something simple. But okay, so what's interesting about this lamp? Well, it's the base is solid concrete. Then it has a kind of a little threaded pipe, just like any standard lamp. Then we have a brass socket, and then we have an Edison light bulb, right? So, any designers here who can raise their hand? Any product designers? Architects? Okay, so Mateus is a product designer. How would you, well, you know, there's already you're seeing some of the molds, but what are the challenges about making this? Assuming, I mean, if you wanted to make a mold for this, what do you think are the challenges?
I would say the main challenge is, embedding all of the different equipment that you need, such as the cord and all, into the concrete piece, because you have to plan for that, right? If you're including that into the molded piece already, like the channels for it, correct?
Right, exactly. So let me see if I can turn this. Can I move this? I guess not. Well, you can see that there's, the part that is going to be apparent in this product is the outside, right? And you can tell that
you can move it now.
Yeah. Okay. Oh. Okay. So. Oh, that's cool. So the bottom part, this is the part that doesn't have to be super smooth, right? So so we have the option. Let me move it here. I'm gonna go through the cable. Okay, there you go. So this part doesn't have to be super smooth. Now, how do you pass this cable through the block? Because remember, this is going to be a mold, and it's going to be cast from this side. So that was one of, I mean, there's options that are not as elegant. We could have drilled a hole here at the end, right? Or we could have drilled a hole here, or maybe make like a channel and leave this outside. But there's a very short distance, small distance between the base and the table, right? We just had some protection, like cork protection here. So, and again, so if you think about it, when you, where is it? Oh, sorry. Grab it again. In most cases, you're gonna pour this by gravity, not by pressure, like in plastic. So again, you would have to, let me make it smaller. There you go. So you would have to cast from the top, right? So you have the mold that is upside down, and then this is open. In this case, this is a relatively easy mold because it's open, all this area, right? So you're gonna pour it here. The cable is not gonna be here, but you have to make this, leave the space for the cable. And then the other thing is that you have to have an embedded little tube that will, where this socket is going to be screwed, and then you have to pass the cable, right? So, by the way, if you want to do this with a plastic, plastic injection mold, this would be really, really difficult, right? Making this little hole for the cable. So let me turn it back. All right, any questions there? Okay. So let me actually go over there. Oh, thank you, Matthias. I appreciate that. So let me go all the way to the other side to show you how this looks in a section. Okay. By the way, Mateus, thank you so much for helping us with this. So we had the 3D models, but Mateus helped us make them ready for the stage. So this is really good. Thank you, Mateus. So this is how it looks as as a section. So let me see. As I mentioned before, this is going to be cast from the bottom, and then there's going to be kind of a channel that goes where the cable goes, and then you have this is a steel, very small steel, the very standard little tube that the socket is gonna be attached to. All right. So how do we do this? You know, and by the way, Fran and I have had so much fun. You know, Fran lives in Argentina. I live in the U.S. I'm originally from Mexico. And we've met in person maybe 2-3 times. Everything else we've done over the internet, different ways. He uses SolidWorks. But we've had so much fun developing molds. Sometimes we fail, sometimes we've succeeded. With this one, we succeeded. So this is how it works. Let me see. All right. So we have this little silicone. So we're using two. Oh, this is another thing. Most of the molds that we produced are made of elastic materials, right? So this is the yellow part is urethane. Urethane is cheaper than silicone, but it doesn't have the same amount of elasticity, right? You can open it, but you're not gonna stretch it like 3 times, so because it would break. So the mold, if you say it upside down from how it's gonna be cast, you have the urethane part. Then we produce what we call a core made of silicone, and then we just left a little hole where this we just inserted the little tube. So if you think about this, let me see if I can move it. Oh, it's locked, isn't it?
Mm-hmm.
Oh no, it's not locked. So all right. So let's turn it. This is how we cast the product right here. All right, here you go. So this part of the wood wouldn't be here. This was just used for, you know, for producing the urethane. But so this is cast from the top. There's some little details that it might be hard to see here, but you know, even this little chamfer here, we're trying to avoid any work after the piece is cast. So, you know, we have this little get chamfer that will help us keep, you know, the edges kind of, you know, not too sharp, and you can see it around the mold as well. So, how did we do this? We have a clean mold. We place the little tube, and then we inserted this little core here and here, and then we cast the product. Again, with the admixtures that we use. Fran, how many minutes or how long did it take from casting to actually being able to release this from the mold? Like 10 minutes, maybe?
30 minutes, maybe. Yeah, maybe.
Yeah, I think even
half an
so.
hour.
There's actually
even
two steps. Yeah, it was less because so there's 2 steps, right? Just to be able to get it out of the yellow part, it was like 10 minutes, 10-15 minutes.
Yeah,
This we had to pull this out, right? So we push from the top, and because this is super flexible, we just pull this out. Then it left that little hole where the cable goes inside, right? How did we make this this core? I'm running out of space here. So we made it with this. So again, 100% 3D printed. And by the way, we have, if anybody's interested at the end, I don't know, Mateus, how you want to do this, but we're going to be able to, if there's enough interest, to share, you know, the best 3D printing options, the best super plasticizer. Again, the idea is to give people who are interested the tools and the knowledge to do this kind of stuff. So let's see. Okay. So you can see it's just a 2-part mold, and we just fill it with this part, this red. This is what went in here. Okay. Any questions so far? Right. So, you know, and let me just go over here. I think the last point I wanted to make before I take your questions is this. So as you can see, there's actually, sorry if I'm moving too fast. Let me try this. And I'm, okay, where am I? Okay, yes. There's really 3 parts that had to be 3D printed. One is the base itself. And when this thing opens, you'll see that it's not really the exact same thing as the lamp, right? Like this little cylinder at the top is where that little threaded pipe is going to be installed, right? And then you also see, when it opens again, that it has the place where the core is going to be inserted, right? So there's a few considerations that you need to keep in mind. It's not like, okay, I'm going to, I think whoever, like friend that can develop things in 3D, I mean, you can do something like the lamp over there. But to make the mold, you do have to have some trial and error and considerations for this to make it work. Also, in this case, the outside is a wooden box, which is very easy, and that's why we wanted to show that, you know, you don't need a lot of things. Now, when you produce something that is really difficult, you know, thin, this outside, you know, like the shell, it may need to be like 3D printed, right? So that the silicone or the urethane is very thin. But again, I think this is complex enough to be an interesting project, but this is one of the simplest ones that we have produced. So, you know, other than, you know, planting or like planters or other stuff that is easier, this is kind of has a little bit of complexity. All right, so that's all I have. This is, again, our, we're very proud of what we have achieved, and we really enjoy doing this and sharing with all of you. Thank you.
Awesome.
Right,
Thank you so much,
any questions?
Mario and friend. Honestly, I personally have a lot of questions. I don't know about everyone else. I'll let, you know, if anyone has any questions to ask first. But I just want to say thank you for the presentation, and the floor is open. If anyone wants to open their mic, ask, you know, Mario or friend anything about the process or about the projects that they're doing, feel free to do so. I know everyone has a lot of questions and they're probably organizing their thoughts to ask them. So I'll go ahead and ask something that, you know, came to mind when you guys were presenting. You know, it's clear that there's a process for making the mold, you know, from making the positive out of 3D printing and then making the urethane mold, and then, you know, the extra pieces that go in, like the silicone tube, right, that makes the path for the cords and all. So it's a very specific process in a way. And I would like to know, from a design standpoint, how much of the process, you know, the process of casting goes into the design of the product itself. Is this something that, you know, has to be kept in mind since the beginning, or is it something that, you know, goes through a phase of figuring out how to make that, you know, and then design, you know, the design phase itself is free from trying to figure out how to make it, you know, first design and then figure out how to make it, or, you know, it's a combination of both? I'd like to know that from a design standpoint.
Okay, Fran, you want to start? Or?
Yes. Okay. Yes, the concrete product has a lot of things to consider, because, as you know, the concrete is a mix of water and plasticizers. So before you design the mold, you have to think about the bubbles that produce the casting. So in this case, in the lamp, we decided to cast the product from the bottom to avoid any bubble and brown surface in the top of the lamp. Get the visual surface beautiful as possible. We have other products that the bubbles are a problem. We have to twist the mold and pure the concrete with from other side lamp mold. In this case,
Yeah, I think
this
that's.
product is quite simple.
Mhm. Yeah, I think so if I can add to Fran's comments, so yes, you have to think about the manufacturing process. Obviously, there is an ideation phase, but after the moment you say, okay, we're going to make this in concrete, we have to think about how it's going to be produced. One of the main reasons is that this is gravity casting, right? So when you're making something in plastic or in injected aluminum, then you know that it's just pressure and the direction doesn't matter. I mean, of course, they have a similar process, but to give you an idea, one of the designers, she had to come to our shop when we had our shop in Chicago to learn how things were done so that she could go back and design her things. Like, actually, she's the one who designed the little stool. Well, not the little, but the stools down there. So she had to learn all those things because she was an expert. Her name is Micaela Dorfel, and she's an expert in porcelain and especially in other materials, but the process is very different. So, so you're right. It's a little bit of both, but definitely it's not like you're gonna 3D print something where it doesn't matter. It's relatively simple. In this case, from the beginning you have to think about, like Frank was saying, how is it going to be cast. Some of the issues that you may have with bubbles or with fluidity or different things, or like you mentioned before, Mateus, with resistance. Are you going to need some reinforcement, stuff like that? So yes, you need to think about it.
Awesome. Thank you for the answer. And it's good to know, because sometimes in the design industry, right, especially in design education, right, we are questioned a lot about the aesthetics of something or design, and not often, especially in architecture school, for example, right, which I have the most affinity with. Most of the time, it's not really put in question how this is built, how this is put together. So then seeing you guys present something that, it's a product that you guys produce and it has to be viable. So every design iteration, and every design product has to have the manufacturing, from what you were explaining, already in mind from the design phase. And that may, change the design aesthetics as it goes, because then you have to account for those things from the beginning, instead of wasting time in things that would not be possible, right?
Yes. And I think one thing that Fran mentioned is also very important, I didn't mention, is like this lamp, we just used the 3D print, and the texture was good for that. I mean, it was not a very smooth, but but it was kind of flat, so it was great. Now, believe it or not, when we use concrete, like with the plasticizers and everything, you can copy almost every surface. So if you make a model that is going to look like a mirror in terms of how flat it is, if you use the right aggregates, it can look like a mirror, right? So the mold and the positive is very important, that you have the right texture, because concrete, again, with the right combination of additives and sands and everything, you can make it look exactly like that. So it's going to copy the texture exactly. So that's another consideration.
Awesome.
Right.
And what would you recommend for someone that wants to do a concrete mold and design their, first product in a way? What would you recommend starting with, or, the path to do a first test like this?
Yes. I think the first thing would be to start with something simple. There's actually companies, and I think even in Amazon, that they sell some of the silicone molds. So, but again, this is mainly for little planters and candle holders and stuff like that, which is it's a good way to start, right? So, making the silicone molds has it's a little bit difficult depending on the type of silicone. So, if you want to start by playing around with the material itself, with the mix and the aggregates, it's a good way to start. And then after that, if you know, or like in my case, I don't know how to design 3D, but Fran is a beast for 3D design. So we worked together, and then we started. And by the way, we're saying these things because we failed many times, right, Fran? You know, we've tried things. I'll give you an example. Um, we designed a candle. It's like a very thin candle holder. It's almost like a pipe, but it was like an S, right? So we decided to make it in two parts, so it was going to be easy to separate and then take it out. Well, it turns out that it's really hard for concrete to avoid this parting line, right? So it looked pretty bad. We decided to make it in one piece. So there's also a little bit of trial and error. I would start with relatively simple pieces and then take it from there. And again, I mean, if there's interest, that's one of the things that we wanted to get out of this. I mean, obviously, we want to share as much as we can, and if there's the interest, we would like to, you know, have some kind of platform to share these. So if somebody asks us, you know, what kind of plasticizer should we use, or what are the challenges, you know, there's got to be a good platform to, I don't know, if maybe a Discord or something. So we're open to, you know, trying different things to work with designers.
Yes, of course. And by the way, if anyone has any questions, you know, about these sort of things, you can definitely ask them even after the Dive Live. You know, if you have those questions in the Discord, in our Dive Live channel, and then we'll be happy, you know, to have Mario and Fran helping us, you know, answer those questions, help you guys, you know, so you guys take something from this, and you can also, you know, ask, you know, since they have so much experience in this, you know, really get some clarity and help with that for sure.
We can also create a channel in the Discord server that's for certain kind of materials, for example, for concrete. So if you have any questions, you can write them there. We can just create a new channel for that.
Oh, so you guys have a Discord server already?
Yes, we do.
Oh,
and
okay.
Yeah, it would be amazing having you guys in the Discord with us. You know, because then we can, you know, collaborate. People,
yeah, definitely.
Some of the people in the community already have been doing amazing work and sharing with us. So you know, we can be this conversational type of scenario that, you know, we're sharing ideas and how to make that possible. So we all benefit from this, right?
Yeah.
Does anyone have any questions for Mario or Fran regarding, you know, design of modes or product design?
Hello, my name is Amanda. I want to make sure you guys can actually hear me first.
Yes.
Oh, okay. Hi, I'm the person that Mateos introduced at the beginning. I'm a student of architecture at Florida International University and working in the RDF lab. I had a question kind of jumping off of what Mateos said about, you know, my knowledge is based on what we're learning in school, and that is mostly in regards to design and aesthetics. So now we're really getting into like the nitty gritty, the details, the tectonics of how things come together. I'm currently working on a mixed use high rise in Miami as my semester project, and I am focusing on using hempcrete blocks as my main form of construction. I just wanted to hear your take on, you know, what the future looks like with those hempcrete blocks and how we can sort of have a deeper perspective of that, the impact, both aesthetically and construction-wise.
Sure. Thanks, Amanda. And by the way, just to let everybody know, so I'm actually working, Fran and I are working on a completely separate project, which is related to hempcrete. So hempcrete is a, sorry, Amanda, go ahead.
No, go ahead.
Okay, yeah. So, I mean, we didn't talk about hempcrete here because hempcrete is a completely separate thing. It's a material made of hemp, so the core of the hemp and lime, and it's not a substitute for concrete, and it's mainly a material that is used, first of all, as insulation, but it also replaces the you know, a system, right? So in the US, we use like multi-layer systems, like you have the structure, you have the insulation, you have either bricks or siding, different things. So one nice thing about hempcrete is that you can just use that as to replace 3 or 4 layers of for a normal system. So one thing with hempcrete is that it's not load bearing, right? So you need to combine it with other materials to build a building. And but it's in the US now, it's legal to plant hemp, and there's a lot of interest in growing hemp for industrial uses like this. So the opportunity for in the US to replace traditional systems with hempcrete is huge. And I know of the different buildings. For instance, there's one in France. I believe it's a museum or a library. They used all hempcrete, exposed hempcrete, talking about, the aesthetics, that it's just beautiful, right? They're combining other natural materials like wood, and it's just, I think just like we were talking about how concrete, like regular Portland cement concrete like this one, is to designers kind of a new medium. I think I see hempcrete as a new medium for architects to explore and develop new things that are going to be super green. So I don't know if that answers your question,
Amanda. Yeah, no, thank you. I all of that information makes sense, like with the research that I've done so far, and along with everything that you've shown as a designer, learning to become a designer, working with 3D printers and robots and resin and all kinds of these different materials. How do they work together? How do they perform to create quality products and overall design? So thank you very much.
We'll be glad to be in touch after the call. And just for everybody, there's also information, at least about so again, we're working on 2 different projects. One is IntoConcrete. So if you go to IntoConcrete.com, you'll see the designs and some of our history, and you can contact us also, or we'll join the Discord server. We are also working on this other project that is called Oku Carbon, that is the one related to hempcrete. As you can see, both are really focused on sustainability, on CO2 reduction. So we're kind of expanding our reach. One with product design with concrete, and the other one is more with construction materials with hempcrete. So it's two different projects. And Fran and I don't know, can you bump Fizz? Probably you can, because anyway, so Fran and I are working on that also with Carlos, I think he's left. Anyway, so again, IntoConcrete.com and okucarbon.com. That's where you can find more information. Any other questions, anybody? So, maybe it's time for a cocktail, right? Downstairs?
Yeah, time for a cocktail. And okay, so I wanna, well, first, here's the cocktail. Mario, if you wanna grab it.
There you go.
I want to thank everyone for being here, and thank Mario and Francisco for this amazing presentation. And one thing that I would like to say that we were talking about in the beginning is, yes, give me all the love, is that if you guys are interested in product design with concrete, we are organizing a submission way that you can submit an idea. So we'll send the information, the detailed information on Discord, but you can submit an idea, a sketch, a rendering of what do you think would be a cool project to do with, casting a product design with concrete. And then we will select one of these submissions to actually have some help and, how to make this mold, how to make the 3D print for it, and the materials, necessary to actually make a reality. So keep an eye on Discord. We'll share the information, and then one of you can have a chance of having your first product design into this, from design to manufacturing process to figure out in person, how to actually put this together. So if you're interested, keep an eye on Discord. We'll share information. Mario and Fran are going to join us in Discord as well. So thank you all very much for being here. It was honestly a treat. And then for the next week, we have already like an amazing dive live already prepared as well, which will share the information with Kat Frazier from It's Animated Text, which is an amazing account doing communication in the 21st century using I don't want to spoil too much, but you guys are gonna see it's actually pretty interesting. So thank you all again, and yes, fly deep. Have a good Friday, everyone.
All right. Thank you, Mateus. Thank you, Camilo,
Hi,
for the
thank
invitation.
you.
And thanks everybody for attending. We appreciate it. We'll have to do the. Thank you. Fran, this is for you.
Oh, thank you.